Hello friends, welcome back my YouTube channel MS Maths. In this video, I will discuss the concept of limit superior, limit inferior, and its important result and example of sequence of real number. This is the part 4 of sequence of real number. You can watch my previous videos in my playlist of YouTube channel MS Maths. This is helpful for IIT JAM, CSIR-NET, and GATE. My name is Manoj Solanki, and I will start the topic. You are getting the concept, and if you are really understanding the topic, so you can like the video, please share the video and subscribe the channel and press the bell icon to get the notification first. So I will start from limit superior and I will discuss over 20 plus results over this and with the examples. So we with the end of this video we will get the so many concepts and so many results. So first of all, I will start with the definition of limit superior and limit inferior here. So I will start with the limit superior. Okay, limit superior, and whatever we will discuss, that is limit inferior. So what is the limit superior? Okay, limit superior. So let's say my an be a real sequence, or we can say the sequence of real number, and m of n is nothing but the supremum of an plus 1, whatever the sequence here. Okay, so it means my m1 is nothing but the supremum of a1, a2. Okay, and let's say m2 is the supremum of a2, a3 over here. Okay, and similarly m3 is nothing but the supremum of a3, a4, and so on. And let's say my mn is nothing but the supremum of an plus 1. So clearly from here, sequence of these supremum, that is m1, m2, and mn is monotonically, decreasing sequence. Because of that, if you are taking the sequence and you are taking the supremum over here, so it will be monotonically decreasing. It will be monotonically decreasing for real sequence. Let's say just take any example of n 1 by n. Okay, 1 by n. How will you relate this? So what is the supremum of, or what is the supremum of this? Let's say starting from 1, 1 by 2, 1 by 3, whatever. The supremum is 1. Now if I will remove the first term, then it is what? 1 by 2, 1 by 3. Now it is what? 1 by 2. Again, if I will write 1 by 3, then that is 1 by 3, 1 by 4, then the supremum is 1 by 3. You can see this is the sequence which is monotonically decreasing sequence. So from here, the limit n tending to infinity over the supremum of an is nothing but the limit an and tending to infinity, which is the limit superior, or we can say that limit n tending to infinity of all these mn. This is nothing but my supremum. We can consider it as m, or this is the notation. Okay, this is the notation which we will use for limit superior. This is the concept of limit superior. Okay, now take one example, the whatever we have taken earlier, that is something an, and which is 1 by n. Now if what is the supremum of this? So supremum of 1 by n is nothing but 1 here. Okay, or we can take that is 1 by n, or we can take mn is equals to 1 by n here. So from here, if I will take the limit n tending to infinity of an, and it's okay, wait, or limit superior, then what will be 1 upon infinity? That will be 0. The limit superior is going to be 0. But what is the limit? Okay, just forget about it. What is the like m1 and m2 here? So small m1, m2, m3. Okay, what are this? That we will discuss. That is nothing but 1, 1 by 2, 1 by 3. Okay, that is what? It's not the sequence. That is the supremum of all these things. Okay, then it will go up to 1 by n again. So if I will take as n tending to infinity, this will go to 0 only. That is nothing but your limit supremum as n tending to infinity for this a, or not an, that is 1 by n. So this is all about the example. Okay, now next we can take one more example here. Let's say example number 2. If it is n, then what about n? So first of all, what is mn? Is the supremum of this n, or we can say n plus 1, n plus 2 over here. So it is nothing but my mn is going to be infinity, whatever the supremum, because the supremum does not exist for this particular, because it will be infinity. So here, so the limit inferior will also for this n is going to be infinity. Similarly, for minus 1, it will go to minus of infinity. Okay, this is all about limit superior. Now we will discuss about the limit inferior. Okay, now we'll take the infimum in that case. So similarly, let an be a sequence of real numbers. Okay, then mn is nothing but the infimum of this an, or yeah, an plus 1, not an plus 1, that is an plus 1. Here it is n plus 1, and like this. So it means that whatever my m1, that is nothing but the infimum of a1, a2 up to an. Whatever my m2, that is infimum of a2. Will start from 2 only, a3. Okay, and after that it will be n3, that is infimum of a3, a4 up to like this. Okay, so from here it is like that. If clearly, now from here mn is nothing but the infimum of an plus 1, whatever it is. So from here it will be strictly monotonically strictly increasing. So, or sorry, not strictly, monotonically increasing, we can say monotonically increasing. So clearly it is monotonically increasing sequence. Which sequence? mn sequence is monotonically increasing sequence, and it is denoting by the limit n tending to infinity to this mn here, and it is denoting by this limit inferior of n tending to infinity of a. Okay, so this is all about the limit inferior. Now we can take one example here. Let's say an example that is 1 comma 2 comma 3, 1 comma 2 comma 3. What is the infimum here? If we'll take the infimum, always it will be n. So the infimum of this sequence is going to be 1. So it means the limit to this 1 is again will go to the, from, because of that, if I will remove this term, again 1 will be there. It is a repeating. If I will remove till here, again 1 will be there. So every time the infimum will be 1 here. So the limit limit inferior is going to be 1. So let's take one more example, that is minus of it. In this case, it is what? Minus 1, minus 2. Okay, this one is limit superior. Limit inferior is for minus infinity. So for here, it is limit inferior. Infimum is what? For this case, is going to be minus infinity. If I will take minus 2, minus 3, then it is what? Limit infimum is what? Minus infinity. So it means that every time it will be minus infinity. So you can take the limit n tending to infinity, that is going to be limit inferior of this an is minus of infinity. This is the concept of limit inferior and limit superior. Next, Next, we will discuss some results on this that will be very, very helpful for you. Some important results. Okay. First result. Yeah. So if you have first result is like this, sequence AN is unbounded above. Okay. Sequence AN is unbounded above. It implies, double implies that limit inferior of AN will be infinity. It means simple. What is the example you can take? M. It is unbounded above and limit inferior is infinity. Okay, first result that you can write here, limit inferior of AN will be less than or equals to limit superior of AN. Okay, that will be your first and this is going to be second. Now, third result. So the sequence AN is bounded above. If it is bounded above, then if and only if the limit infinity of AN will be finite or not plus positive. Not finite, we can say it will be plus positive. It will not be positive infinity. Not plus, it not plus positive. Okay, I was okay. It was not plus infinity. Okay, so minus of n, it is what? And it is what bounded above. Let's say minus 1, minus 2. Here it is what? It is nothing but bounded above. So it means it is minus infinity. So the limit inferior for this, what is the limit superior of this AN is going to be minus infinity, but not minus plus infinity. Okay, so I will explain all the result using the examples. Next we have sequence AN is unbounded below. Unbounded below. So it is if and only if limit infimum of this will be infinite. And take minus n. Example minus n. Okay. Next, if my sequence is bounded below, is bounded below, then if and only if, then I will have the result if and only if it will be limit infimum of AN will not be equals to negative infinity. Okay, for example, n, it is what? 1, 2, 3. It is nothing but bounded below. So what is the limit infimum? Limit infimum is, sorry, yeah, limit infimum will be plus infinity for this example. Okay, next. Because if we'll take the infimum, that will be 1, 2, 3. Okay, every time it will be 1, 2, 3. If we'll truncate from here, first term, second term, then it will go up to infinity only. If we'll take the limit of that sequence, that will be infinity. Yes. So the sixth result is related to the sequence of AN is bounded if and only if limit of AN and we can say the limit supremum of AN and limit infimum of AN are finite real number. Finite real number means if sequence is bounded, then limit supremum and limit infimum are finite real number. If limit supremum and infimum both are finite real number, it means my sequence is bounded. Okay. Next we have seventh example. Yeah, that is what? For bounded sequence AN, limit supremum of AN is equals to the largest limit point of AN. Okay, and limit infimum of an is going to be smallest limit point of an. Just take one example. So for this an, let's say 1, 2, 3. 1, 2, 3. What is the concept of limit point? Limit points are those which will be repeated infinitely time. In this, these three terms will be infinitely time repeat. So second, the set of limit point is going to be 1, 2, and 3. What is the infimum of this? So limit inferior of this an is going to be 1, which is what? Smallest limit point. And similarly, limit inferior of this an is 3, which is the largest limit point. So this is the concept. You can take example. You can take one more example. Just take example -1 power, and here the limit points are 1 and -1. So the limit inferior, this is what? The superior. Okay, limit superior. But how will we define? Note like this, limit superior, and this will be the limit inferior. Okay. Next, eighth, sequence an is convergent to L if and only if limit superior of an is equals to limit inferior of an, which is L. This is one of the important result. It means sequence an is converges, then an is bounded with unique limit point. This is nothing but this is showing that unique limit point. Because of that, this is nothing but what? The largest limit point, and this is what? The smallest limit point. So if it is largest limit point and smallest limit point will be the same, means unique limit point. If there exists unique limit point, then my sequence will be convergent only. That's the simple concept. Okay. Next, ninth number result. That is something sequence an diverges to plus infinity if and only if limit superior of an is equals to limit inferior of an, which is positive infinity. Okay, and similarly the sequence an diverges to positive infinity, it means that limit infimum of an is positive infinity. Next, sequence an diverges to minus infinity, it means that limit superior of an is equals to limit inferior of an is equals to minus infinity. Okay, and a sequence an diverges to minus infinity if and only if the limit supremum of an is equals to minus infinity. This is the one of the important. See this result and this result. So whenever it will go to positive infinity, it is implying that the limit infimum is going to positive infinity, and here it is what? Limit supremum is going to minus infinity. This is the important result you can take. Okay, next, 13. So sequence an and its limit supremum is infinity and its limit infimum is of an is L, which is a real number, it means that what? An is nothing but oscillate sequence or oscillate infinitely times. Okay, this is the result. Next, if you have limit supremum of an which is minus infinity, limit infimum of am which is L belongs to real number, it is also oscillate infinitely time. Okay, 15th number result is saying that limit infimum is equals to positive infinity, limit supremum is equals to positive infinity, limit infimum is also positive infinity, and it is also oscillate infinitely time. Okay, these are the meaning of the result. Next, we have a result related to like this. Limit infimum of an is some L1 and limit infimum of an, let's say some L2, where L1 and L2 both are not equal. Then also oscillate infinitely times. Okay, next 17. If your limit infimum, if you are checking the limit infimum of k into an, then it is nothing but k into limit infimum of an. If your k is greater than 0, then k into limit infimum, that is the limit supremum, and limit infimum of an if your k is less than infinity. Okay, if your k is positive, it means that if you are finding the limit superior, okay, of what? Let's say 2n. Now, if your 2 is positive, it means the limit superior, which will be multiplied like this. And if you are finding the limit superior of this, or let's say minus of 2n, then limit superior will be the limit superior of this will be the limit inferior of 2 into n. Okay, because of that this minus. Now just calculate the infimum, how it will look like. So just calculating the limit infimum of Kan, just understand the concept carefully. If k is greater than 0, then it will be limit inferior only. It will be limit inferior only with a, with multiplied with k. If it is negative, then it will convert to limit superior. So k into limit superior of this a. That's the concept. Okay. Next we have result 19, that is limit inferior of an, which is less than of limit inferior of a subsequence, which is also less than of limit superior of a and k, which is also subsequence, and which is less than of limit superior of an. This is something like this. Limit superior and limit inferior will be the infimum and supremum, and all the subsequences or all the limit superior and limit inferior of subsequences will inside these both. Okay, this is the concept. Next, it was 19th, let's say 20th result. So an, if an is less than equals to bn, it means that limit infimum of an is less than of limit infimum of bn. Okay, one of the result, and limit supremum of an will also be the limit less than of limit supremum of bn, except the case of infinity minus infinity. Okay, here it is infinity. If it is not going to infinity, then we can consider. Next, for 21, result number 21 that we can consider. So the limit of an plus limit Okay, limit infimum of an. Wait 1 second. Limit infimum of an is plus limit infimum of bn is less than equals to the limit infimum of an plus bn. Yeah, and less than equals to the obviously the supremum of an plus limit infimum of bn, which is going to be limit infimum of an plus limit supremum of bn. This is the result. So these all are the case here. And next we have some result related to the sequences, which is positive sequences. Let's say, okay, 22 for positive term sequence an, we have limit an plus 1 upon an less than of, this is something limit infimum and limit infimum of nth root of an and limit supremum of nth root of an less than of limit supremum of an plus 1 upon an. This is for positive term, okay, not for negative because radical is here. Okay, square root is here, okay. So root test is better than the, so you can see here the root test is better than the ratio. This is called ratio test, and this is nothing but root test here. So from here you can say limit an plus 1 an is equals to limit n root of an. Okay. Next you can see that is D'Alembert limit, if that is called D'Alembert limit. Okay. That is also something like this. If you will take, if your an be a sequence such that an are non-zero, if your limit x tending to infinity an plus 1, sorry, and tending to infinity an plus 1 an is something L. Now, if your L is less than 1, then an, the limit will go to 0. If it is greater than 1, then it will be divergent. It will be divergent. If it is less than 1, then it will be 0. Otherwise, it will be okay. This is all about the result of limit inferior, limit superior, whatever the discuss we have concept we have discussed. So thanks for watching my video. Keep watching MX Maths, and thanks for being the end of the video. We'll meet you in the next video. Thank you. Bye bye.